Hello, my name is Josh, and today I'm going to be showing you a level generation system that I wrote for a game called Steelpunk, which is a MMO FPS where players delve into dungeons, subterranean dungeons, in an Earth conquered by a hostile AI. Now, I showed you last time some of the gameplay. This time, unfortunately, we're not going to see any of that cool MMO FPS gameplay. We're just going to see a testing environment for the basics of a new level generation system. I showed you last time how the rooms worked, how each room spawned its own doors and its own adjacent rooms, but we're going to refactor that into one level generator that generates the entire level at the start, on awake instead of at runtime, so we can guarantee that an exit room spawns, an entrance room spawns, and so we can just, take the flow out of the code, separate the flow and the function. So let's just see a test right here. Now this is only half complete. It's not random yet, and we only have 1x1 rooms. But the idea is that eventually these will be randomly selected, and you'll have different sized and shaped rooms that will rotate to match to these free doors. But right now the algorithm just finds a free door, one of these little black rectangles on the sides, selects a room. Right now it's just like going to be one of these 1x1 rooms to spawn there, and then iterates back, adds its doors to the free doors, all that good stuff. And we also have let's collapse all this, a test log. This is actually printing out the map, so you can see this kind of matches what we saw in the test. And this is actually just a 2D array of Boolean flags. So these pluses represent true values, and these spaces, blank spaces, is just printed if there's a false value. And this is how we keep track abstractly in a data structure, the map that we have. We also have the rooms, and each room has its doors listed. And these are actually classes in the level generation class, So we can see the room. It has its coordinates and its doors. And we have door, which has its rooms, its local tile, so which tile of the room it exists at, and its global tile, which is something that's used for an actual instance, which is basically just its local tile added to its room's coordinates, which I think is actually implemented it's in the constructor. And these are totally abstract. They're vector 2ints. They're not actual transforms. Even though we do store transforms of the actual rooms and doors in these dictionaries here. So we have printing out the data structure here. We have our list of rooms. Each room has 4 doors. And we should see in here a list of doors, right? And most doors have 2 rooms. We can see that we have its global tile. Every 4 doors we get a new global tile, because that's just how it works. And then the rooms. So this door at 0-1 obviously will have rooms adjacent to it, and if it faces west, it's going to have rooms adjacent to it at 0-1 and -1-1. So actually this it's in the west. It's facing west, so it's actually you could say it's also east of -1-1. Some doors though only have 1 room, and these are the ones that are free. These are ones that could have another room next to them, and this is how the whole system works. Is we actually, if we hop into here, we're going to iterate through the free doors, right? We have a data structure, we have a list of the free doors, and we iterate through it to first select 3 things randomly. And it's not actually random right now, but it will be eventually. We're going to select a free door, we're going to select a room config to spawn adjacent to that door, right? And we are going to pick a door of that room, which to match to the free door, right? And eventually that will all be randomly selected, but right now it's really just iterating through the free doors. Because we only have one kind of room, we just have a 1x1, and we're not rotating the room, so there's only one matching door. But eventually we will rotate the rooms of different sizes and shapes. And eventually will be random. We're going to have a list. We're still going to have these lists, but it's going to shuffle in place every time. And in order to mutate that list, we actually have these like other lists that we add to. While we iterate through, we're going to add to these lists, and then at the end, we add to the free doors what's in new free doors, and we remove from free doors what's in no longer free doors. But you'll see that. I'm trying to get through this one a little faster than the last one, because the last one took a long time. But you can already see how this starts to solve the problems that we identified with the RAID room manager. The RAID room manager, it has its flow hard-coded. Now, like, the generation is entirely independent of the RAID room manager. We can guarantee the spawns of certain rooms, like start room and end room, anything we want. And it also supports, very naturally, it supports rooms of different sizes and different rotations. Yeah. So let's walk through it pretty quickly. We'll like skim through a lot of this stuff. I skipped over Awake. Awake just spawns the first room. You can see it instantiates it here. It adds it to the map, which again is just a 2D array of booleans. It creates a new instance of a room, adds it to our dictionary with its actual transform, the vector3. And this is all like, this is still being built, so might change up some of these data structures to fit what we eventually need. But I tend to write a lot of tracking stuff, data structures for debugging, and just to like write it in there in case we want to keep it later once we're done writing the actual system. We also spawn the doors. This is a lot here, but I'm going to skip over it right now because a lot of it is repeated later on in the like iterative function, and that's another one of the problems with this script right now. First off, it's not finished. And second off, it has a lot of redundant code that could be rewritten as separate functions, which is going to be the first thing that I do once I finish actually writing it. So yeah, this isn't finished, but I did want to show the process, and I'm excited about it, so I wanted to share it. So anyway, we have this routine generate. We have our spawn quota. It's 32, that's why only 32 of them spawned eventually, and it just kind of halted. I have this while loop. I learned yesterday how to debug while loops, which is just to not have them until you're absolutely sure that it works, because otherwise it is annoying. So that was a good lesson. Right here, we have iterating through free doors. Have another check for it. This is where eventually we'll iterate through a randomly shuffled list of rooms. So right now we only have one room, the 1x1 room, so we just get that. And here we iterate through that room's doors. And we're going to find a matching door. This is a bit of modular enumerator math that I had fun coming up. It just kind of like came to me, so it was fun to see that it actually worked. This first part here checks that the rooms, basically, they're listed as going clockwise. They're northeast, southwest. So matching doors are going to be like every other. So like north matches to south. So this just gets that they have the same like evenness. And then this one just checks that they're not the same, right? Because if you want to match a north door with a south door, not another north door. So this is where we get a lot of the information on its position. And you can see here we have both its tile position, where it's going to go in the map, where, you know, we take our units down to just like the one unit. We don't, we're not actually interested in the world scale. But then we actually do have world position for both the doors and the room. And this is where we take the tiles, we cast them to a vector 3, or we actually construct a new vector 3 instead of just a vector 2 int, and we multiply it by the world scale, right? There is some fun stuff going on here with the face, right? The face of the door is going to determine how it's offset from its tile, because it belongs to a tile, but it's never actually going to be positioned at that tile. So we store that tile in its face for, you know, that information, but when we actually want to get the world position, we need to do some stuff with that face offset, right? We have the tile world position, we have a world face offset, and we combine them to get the world position. The tile also influences the rotation, right? If it's a north-south door, we want it to be, you know, like, you know what I mean. We want it to face that direction. And that's where this switch statement here comes in. I'll expand this really quick, but it's just a lot of like, you know, if it's north, you know, its offset is up. You know, its rotation is 0. You know, that kind of thing. So all this is just so that we can check for occlusion. And remember, we haven't actually picked this. We haven't spawned anything yet. We're just picking a free door. We've picked a room, and now we've found the door that matches. So we're just putting all this together, and now we need to see if it's valid. If it's not valid, then we're just going to iterate, right? But if it is, then we're going to spawn it, we're going to break out of that loop, and we're going to reshuffle our list so we pick a new random one. Again, that shuffling isn't actually implemented yet, but it will be. Checking for occlusion, right? This is where our map data structure comes in handy. We just check if it's true or false there. Right? There's our check. And we actually check every tile, you know, if there would be multiple tiles. And this is where we spawn, if it's not occluded. We instantiate the room. We add its tiles to the map. We create a new room instance, you know, that inner class. And we add it to our big dictionary. Same thing with the doors. We do a similar sort of thing. We have the same sort of switch statement. Again, this is something that should be separated into its own function. I haven't designed exactly how that's going to work yet. So I'm just, you know, building it out, making sure it all works before I make it really clean. Same sort of calculations. We saw this in the last one, how if it already exists, if it's in our big dictionary of all the doors, then we actually know that door now has 2 rooms opposite and can now actually be opened. And we're actually going to remove it from the free list, but we can't mutate the list of free doors while we're iterating through it. Or that's not this one. So we add it to our no longer free doors list, which will edit, mutate the free doors list at the end. This is where if the door doesn't exist already, we instantiate it. Same thing, we add it to the data structures, add it to our free doors. We create a new instance of it. And then we increment our spawns, keep track of that, we break out of our loop. This is where we update our lists, shuffle the lists, you know, if we were shuffling them right now, which we're not. And that's it. So, to summarize, how it works is we pick a free door, we pick a room to spawn adjacent to it, and we pick a door to match with it. And that's basically it. It seems simple once it's all written out. It's been fun to write, and I'm really excited to, you know, make it more complex, to have different sized rooms, lots, you know, the different edge cases, be able to turn this into some cool gameplay. instead of just this testing environment. But I got a lot out of learning how to like write to a file from Unity, just so I can test this stuff. I think this is going to come in really really handy for printing out our data structures. You have a lot of print methods here. I'm going to learn how to use randomness and shuffle this stuff, so I'm excited for that. Problems, it's not finished yet. It has redundant code, and configuring the doors is also a bit tedious. We can see that here. This is where's the config? Here's the config. See, we have our list of rooms. This is the room. It's tiles. It just has one because it's 0, 0, and it has its doors. This seems a bit tedious. I feel like this could be reworked. But yeah, that's about it for this time. I will hopefully make another video when this is complete, and we'll actually be able to see it working in the game. Until then, thank you for watching, and I will be back next time.